Hi children, this is a review and reinforcement video for 14.2 polygons in the coordinate plane. First, let's review what a polygon is. A polygon is a closed plane figure formed by 3 or more line segments. It needs to have at least 3 points also. So, different examples of polygons. We have triangles, a 3-sided figure, rectangles and squares and trapezoids and rhombuses, 4-sided figures. Okay, pentagon, 5-sided figure, so on and so forth. So it has to have 3 line segments minimum and 3 points at a minimum. So the first thing we're going to do is we're going to practice finding the perimeter of this polygon right here. And remember, perimeter is the distance around the outside. So let's take a look at the distance around the outside. So let's count the number of squares along the outside. So we have 1, 2, 3. So I can go ahead and put 3 on that side. If this side is 3, then that means this side is 3. Let's go ahead and count the other side. 1, 2, 3, 4. I can go ahead and label that 4. And if this side is 4, we know that this side of our rectangle has the same measurement. That side is 4. So let's take a look. How do we find the perimeter now of this polygon? Well, to find our distance around the outside, we're going to add up all the sides. So 4 plus 3 plus 4 plus 3. So our perimeter of this polygon is 4 plus 3 is 7, 7 plus 4 is 11, 11 plus 3 is 14. So 14 units. And it is not square units because we did not find area. It's just regular units. Now, let's find the area of that same polygon. Area, we're counting the number of the squares inside. Now, if it's a regular polygon, like a square or a rectangle, or even a triangle, we could use our measurements, but we could also count the number of squares on the inside. So let's count the number of squares on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our area of our polygon or our rectangle is 12 square units. Remember, area is always square. We could also do length times width. 4 times 3 is 12. So when you have a regular polygon, you could use the formulas to find area. If you have an irregular polygon, then you would just count the squares on the inside. Okay? Let's look at our final slide. Reminder, a polygon is a closed plane figure formed by 3 or more line segments. It needs to have at least 3 points also. So let's answer a few questions. How many polygons can be made with the following? So if we have 1, 4, so if we have a point at 1, 1, 4, and if we have a point at 3, 5, so we start at our origin, 3, 5. I'm going to draw a line to connect those 2 points, which we would call our line segment. Can we make a polygon out of this? Let's take a look. A polygon is a closed plane figure. First of all, it's not closed, formed by 3 or more line segments. How many line segments do we have here? We have 1. It also needs to have at least 3 points. We have 2 points, so none. We can make no polygons out of just 2 points. Let's take a look at question number 2. How many polygons can be made with the following? So if we have a point at -3, +2, I'm going to plot my point. If we have a point at -4, +4, I'm going to plot my point. And if we have a point at -1, +3. I'm going to go ahead and connect my points using line segments to create a polygon. So let's see, how many polygons can we make with these 3 points or any 3 points? Well, let's take a look. Is this a closed plane figure? Yep, it's closed up. Does it have 3 or more line segments? It has 1, 2, 3. So yes, it has 3 line segments. Does it have at least 3 points? Yes, it does. 1, 2, 3. So how many different polygons can we create with 3 points? You got it. Looks like 1. We can create 1 polygon with the 3 points. And our last example, how many polygons can be made with the following? So this one's a little trickier. So if we have a point at +3, -3, so we'll go to +3, -3, and then the y-axis. So this is our y-axis. Remember, this is our x-axis, this is our y-axis. So we could use anything along this y-axis. How many different polygons could we make? Well, look at all these different points we could use. So we could essentially have a point at here and here, and we could create a polygon by connecting our line segments. We could also have points at here and here. And guess what? We could also connect our points and make a different polygon. So could we make more than one polygon using the y-axis and 1 point? Yes, we can. We can make more than one. Now the difference is these would only be 3-sided. So in that instance, we would have more than one 3-sided polygons. Hopefully this has been a helpful review for 14.2 polygons in the coordinate plane. We'll see you later.